what the Yang tools are, what Yang brings to the party in ODL and in general, and talk about the Yang tools themselves a little bit, and then I'll also talk about other communities that are working on Yang models. ODL is using Yang models that are created both here and other places, so we'll talk about where those are, how you can get involved, and then Reinaldo is going to talk about best practices and recommendations and caveats for when you're actually building stuff using the models and the tools. So Yang tools is something that have been around since the beginning of the ODL project. Yang tools are fundamental to the MD-SAL concept. Yang tools are a set of tools that are built around processing the Yang modeling language as an input. Yang itself is a modeling language. And by the way, Yang is closely associated to netconf, but doesn't require netconf, nor does it require restconf either. It provides a modeling language that, the modeling language itself provides semantics and data, organization of data, and models can be augmented, much in the way sort of like we used to do with SNMP, where you had MIBs. So you have sort of Yang modules, which are effectively pieces of a big conceptual tree. And so Yang data is modeled in a config tree and an operational tree, effectively, although there's conversations about doing other kinds of subtrees. Yang provides a couple of important other functions, RPCs, which are important for communication between the client and server. By the way, that's again originally came out of netconf itself, although it's used in other contexts. Just like with SNMP, there are notifications in Yang that can be defined, and how they're implemented is a matter of the protocol that is used. Yang models are specified in ASCII text files, so there's not a magic binary format or anything that's required, so they're easy to process. And I mean, this is maybe a matter of personal opinion, but it's fairly simple and compact and fairly straightforward to understand. Most people that I've ever talked to and shown a simple model can sort of handle that without much kind of information about what's going on. And the latest standard for Yang is defined in 6020, RFC 6020 from the IETF, which is what we use here. So what do Yang tools do? Conceptually, Yang tools in ODL generate Java code from Yang inputs, although Yang tools themselves are effectively a compiler that takes Yang as an input and generates various outputs, or can generate various outputs using what we're calling codecs. In the case of Java, generated classes are mapped to the DOM. And then again, we can output various formats that are mapped to that. And I'll show you some examples of that in a second. What's also cool about this is that the codecs are data driven, right? So you're taking Yang, which is data, and generating various interfaces from that same input, which is really cool, because prior to this, we had to do all this stuff by hand. So I'll give you an example, like in the MD-SAL, one of the coolest parts of how the MD-SAL works is that it's an auto-generated northbound restconf interface that's produced from this tool, and the code is generated from that as well. And so there's, you're taking the human factor out of the process effectively. And so when the compiler is correct and is working properly, which it more or less does now, you generate the right APIs. And also, that same code can be used to not only generate code in the MDSAL today, you can generate code in client applications potentially that talk to that same interface on the other side of the picture. Yeah, and I guess the other interesting thing here too is you can do model translations, right? So you can do with Yang tools, and in fact some of the other compilers that are out there too, you can do like Yang to XSD and so on, which is also interesting. So here's an example of how we go from Yang to using the Java codec to generate Java code. So we take a Yang definition of bridge name, and we're going to generate a public class called bridge name from that. Sorry about the build out here. I thought I took all these out. And you can see we auto-generate a constructor for the class, and voila. And so this is effectively a stub function now, or a stub class, and you go in and you fill in the action functions for this class as you go. So to handle where to go get the bridge name, you may add some other functionality in here. But the general API now for this is generated, which is cool. Oh, sorry, there's another build out in here. So I have a bunch of these examples, but we don't have a ton of time, so I'm not going to run through every single one of these. Here we have a grouping in Yang of bridge attributes, and a leaf inside of this grouping container called bridge name with this type, and we'll see how we generate the sorry about that, but how we generate the class def for that. And again, you would go back after you generate this and augment this. I'll just walk through here. It's a container definition. And I meant to remove some of these. There's too many of these things in here. We tried to, the slides are available online later, so I thought they'd be good to just leave these in so you can look at some good examples if you're interested. Here we have a list. Let's see how we generate. We can generate the searching for the list. There we go. Yeah, and so here's maybe a little more interesting thing. Here's how we generate the RPC. So we have an RPC definition. Whoops. Get back here. Yeah, I know. Thanks, Flash. Go away. Sorry, so here we have definition of an RPC. We have the input and the output for the RPC with parameters. And here's how we generate the resulting Java code for that.
How does the name mapping?
So I think that's actually a typo. It should be hello world. I have to complain. I should have actually thanked Ed for these slides. He did these original slides in Giles. Yeah, the name should match. All right, run through this. Forgot there were animations in here. Come on. All right, here we go. So the Yang to Java is cool because it's got these properties, right? It's consistent. There's a consistent translation. And it handles certain things for you automatically, right? And this is stuff that's generated now, right? So we have these properties that it's immutable. We have strongly typed input and obviously output from that now. It's consistent because, the compiler is generating the sort of the framework for the code here. So again, you take out a lot of the human, fat fingering errors that you've had. And you can improve what's generated too. So if you realize, hey, I'm not generating enough in the stub functions that I could generate, you can always go back and add that. This is a work in progress in a lot of ways. So if you say, well, all of the constructors that I have to generate have to do this, right? So you can go back and add that. And the cool part there too is that you're not going to go do that for the 500 classes that you previously generated. You do it once, and then you just regenerate. And if you're merging the generated stubs with your handcrafted code, that's more or less automatic, which is nice as well. And I mentioned, the automatic bindings for RESTconf and netconf, which come for free in the package now. And also, there's some other stuff coming on the horizon for some other message bus technologies and potentially, things like potentially Python, could be fairly straightforward to work on this. And again, as I mentioned, what's cool here is we're generating code inside of the MD-Sal, for example, here. You could just as easily use this to generate code in a client application. In this case, it would be a Java application with, these sort of, bindings. But you don't have to do that. You could have another codec that could generate different sorts of bindings for you, which is really cool. Other available tools. So one of the things I wanted to make, kind of get some information out on this. I've gotten a lot of questions about how to do modeling, how to validate your model, how to work on that, because the Yang tools themselves don't really help in this regard. So there are other, there are external tools like the Yang validator. There's Pyang, which is another open source compiler, which is on GitHub, which I didn't list here. I should have listed. And Yang validator is a web-based, sort of front end for Pyang. So you can take your model, upload it, compile it, see if it's valid, check on your dependencies and things like that. Netconf Central is something that we've worked a lot with, myself and a couple of other folks. Andy Bierman runs Netconf Central. There's a lot of tools there, other tools. There's a pile of models that are there, examples. There's a lot of tutorials there that can help if you're new to Yang. So check that out. We have a GitHub community that a couple of us started, I don't know, about a year ago, which is associated with a bunch of efforts that are going on, like at the ITF. There's a bunch of netmod models that are there, ITF models that are there. We also have some IEEE models that are there. OpenConfig uses that as their repo. At the IETF, there's a modeling coordination group for routing models, which is interesting for ODL. Might want to check that out. There's a whole lot of modeling that's going on there that's useful. And whether or not we want to consume those models here is kind of up to us, but they're really good examples because there's a lot of people there that are very, very good at Yang modeling. And then if you have questions, if you're doing, you're trying to figure something out in the model, and you can't get an answer, you can also ask the Yang doctors, the ITF. They're called the Yang doctors, but it's about 12 people, and somebody usually will answer your question. I mentioned some of the other communities working on models. So IEEE just started working on models for bridging, for example. Those are on the GitHub repo. OpenConfig, some of you guys have probably heard, like Anis gave a talk yesterday. he started OpenConfig. Their models are hosted here. And MEF, Metro Ethernet Forum, is starting to do models as well, and those might be interesting. So Reinaldo is going to take it from here and give you some recommendations.
All right.
There you go.
Thanks, Tom. Okay. Okay, so this is probably one of the most interesting slides. So let me start by saying that I started using Yang models about maybe 2 years ago when I started developing software for Open Daylight. And in the beginning, I struggled a lot on why Yang, right? And maybe for the new folks here, and maybe some of the experienced folks, right? I think this is important to answer this question appropriately. Why you should use Yang? What benefits does it bring to you in the context of Open Daylight and in a broader context, right? And if you get this, things become clearer, you know? So Yang is a cornerstone of Open Daylight infrastructure, right? I would say is a workhorse of Open Daylight, right? Why, and why is that? Because everything that you do in terms of plugins, interactions between plugins, and data storing information is built with Yang, right? And it allows for a data model-driven development. So what do I mean by that? It means that basically allows you to model something. It can be a router, a switch, a person, a toaster, describe what it does, what its attributes, right? And then get that, compile into Java code, and integrate it in your application. Okay, and so what? The data model is the live representation of the thing that you're working with or working upon. So the first thing that somebody comes when they are joining a project is they look at the code and bitch about the previous guy that didn't document any of the code, right? Oh my God, this has no documentation, right? I'm gonna understand that, right? So Yang provides this kind of live documentation. For me, that's a very, I would say, is very useful. For example, let me give you an example. I work mainly on the service function chaining project, right? And recently we integrated service function chaining in the OVSDB project. And in this process, I wanted to understand more about how the OVSDB project worked. And before I even looked at their code, I looked at the OVSDB models. Just by looking at the models, understanding nothing about their code, I could kind of figure out more or less what they were doing, right? That's the power of this thing, right? Instead of delving 5 months into looking at their code, you kind of hit the ground running. You look at the code, if the model is well maintained, there's the descriptions, you know, there's RPCs, you look at that and say, okay, I have an idea where they're going with this, right? And then you look at the code. And since the Yang model is tied to the code, it forces you to update the Yang model when you want to do something different. It's not like documentation that you say, I'll do it tomorrow, and you never really do it, right? So the Yang model becomes a live representation of everything you do, right? So therefore, I say it's easy to understand the debug issues across applications, right? It gives you persistency and clustering for free, right? Of course, there are a little bit of caveats around that, but you do your code based on Yang, you get that, right? As opposed to something else. If you use Yang models and data store, you get what I call an anonymous point to multi-point messaging system. That for me, it's one of the greatest strengths in Open Daylight. Right? In the beginning, in the service function chaining project, I started using that. People are like, why are you doing this? But it allows plugins to communicate through the data store through Yang, right? In a very hands-off type of way, right? And it provides JSON bindings, RESTconf support, and RPC support. So You put all this together, you figure out why Yang is so important in Open Daylight and in the broader context, right? Okay. So there are a few things that you need to do when you're developing Yang models for Open Daylight, right? There are a few caveats that you need to understand that I went through, and I'm going to give you a few tips. There are the good things about Yang, and the things that there are some caveats that that people are improving upon, and I'm going to talk a little bit about those things. So the first thing is versioning, right? Usually in Yang models, when you update the Yang models, the idea is that you change the revision depending on the changes you do to the model, right? But the classes and the packages that are generated from the Yang models have the revision date in them, right? Therefore, if you go and rev the model, right, it becomes hard to come back here and change all your import statements, right? Even with an IDE, right, it can be tricky. And it can be even trickier if you have, say, two models with different revisions, right? The IDE will try to get the class from one or to the other, and suddenly you find yourself putting all these prefixes, org.opendaylight.this.that, in order to specify the class or the method that you want. So in the beginning of the service function chaining project, I was revving the models a lot. And after the service function chaining project became really, really large, I stopped doing that, right? I'll probably rev when this is adopted by the ATF and become a standard, then I'll do a final revision of, say, the models. There are some model validation limitations that you need to be aware. I mean, if you look at the Open Daylight list, people always trip on that, right? I mean, every now and then somebody asks about this, right? And this is something that it was greatly improved in lithium, and hopefully it will be improved even more in beryllium, and Tony is there in the background, right? I mean, just look at the list of Open Daylight, you see people, every now and then there's somebody that, trips on this, right? So the RFC 6020 has all these constraints that the Yang model and the backend need to provide, right? So if you have two Yang models and one is tied to the other, right, saying, let me give you a simple example, right? You have a Yang model of a car, right? You have a Yang model of a factory, right? And the car and the factory points to the car, right? So today, this is of course extreme example, but today you can basically delete the factory and the car is still there, right? You know what I mean? So, but you should not, right? Because you should delete the car first, and then. So this kind of relationship today is not validated, right? And there are other. I'm not going to dwell too much on this, right? But there are some of these validations that, since they are not done in the model, at the model level, you have to do in your code, right? But I would say that since this is improving, right, I would just keep this in mind, and since it's improving in lithium, it's going to improve even more in beryllium. More and more of these validations are come, and you only probably need to do just small things here and there on your code. But it's something you need to keep in mind, because if you do a Yang model, you test with RESTconf and say, well, I could do this, then you're going to hit some of these things, right? So, and this is what I talked about. The most common pitfall is the fact that path integrity constraints are not validated, right? So I talked a little about this. This is a specific service function chaining example, right? Basically, right, you can basically remove a path, right? Or, right, you can completely remove a path and with the devices in it, but you should not be able to do that. We take care of this in the code, because when we started the service function chaining project was a long time ago. But as this is improving, hopefully this is not going to be needed anymore. I mean, this validation at the application level, right? So in lithium, we recently fixed some things. For example, if you have a Yang model list, you can have minimum elements and max elements constraints. They are enforced for lists nowadays. In service function chaining, we use this heavily, right? Saying you want a path, it needs to be at, you want a path, you want your packet to traverse all these devices, well, we need to have at least one device, right? And it can have at maximum 255 devices, right? And there are many other examples, right? There is something else that is more an advanced topic, but when you're doing Yang modeling, in Open Daylight specifically, there are two ways you can represent a list, right? A list that doesn't need keys, I would say. You can do a list or a lift list. I would urgently suggest you to use lists, right? Even if you don't need keys, you can create like an arbitrary key or say artificial key, which can be 0, 1, 2, 3, 4, 5, 6, 7. Because with a list, with the keys, it's much easier to create instance identifiers to add, remove, update elements, as opposed with lists, right? Because with lists, since there's no keys, sometimes you need to loop through a list to figure out the elements. Let me see what else. Unknown versus identities. This is a big item as well. So unknowns in Yang, they are very nice, but they are not very extendable, right? So anytime you want to convey a list of things that people are going to be free to extend, not only you, but third parties as well, right? The recommendation is to use identities. So this is from the service function chaining project. So a service function can be a firewall, can be a NAT, can be a DPI, can be a load balancer, can be a firewall of a certain vendor, a firewall of, open source. So anybody wants to be able to create a new identity, right? You can represent that as in a big enum and have all these values 0, value 1, value 2, but that's not very extendable. It requires revving the models and things like that. So the idea is that you provide a list of identities, right? So you want to create, say, firewall-foo, you go and create a new identity, right? And then everybody can extend the models with new identities, right? I'm going to give you another example about that. How is it done in the ITF interfaces model, right? And that will become even clearer. And this is what I call the identity interaction model, right? So if you look at these three things, right? These three identities, what do you see, right? You see a specific interface model, which is identity ISO 88023 CSMACD, right? So that is identity of a specific interface, which use as a base type, right, the IANA interface type, right? So you see that you can create tons of identities here. They all inherited from the base interface type. And not only that, the base IANA interface type inherits from the identity interface type. And why that is so important, this kind of identity interaction, right? Because you can create namespaces. For the sake of this discussion, is in fact namespaces. For instance, I could create identity Cisco interface type in parallel to the IANA interface type. And then all my interfaces here, all my identities would inherit from the Cisco interface type, right? And then in fact what I'm creating is this namespaces that instead, so I don't need to touch the base interface type or the identity IANA or the identity Cisco interface type anymore. All I do is add more and more and more interfaces on this list. And this kind of identity interaction is covered in RFC 7223 and 7224, if I'm not mistaken. So this is what I'm talking about, the identity interaction model. So you have easy to create a new namespace, such as identity vendor interface type. Easy to create new interface types without touching or revving the base model, right? So it's very good for open source projects, right? I mean, the service function chaining project, we have many vendors, and sometimes they want to add a new type of load balancer. Instead of saying load balance, they can say load balancer, say Brocade, right? Which inherits from the Brocade identity, which inherits from the base interface type. They don't need to touch the base interface type or the derived interface type, or the derived load balancer, if you will, only all the devices that they create. So this is something that is really, this is like it's like a gem, right? A golden gem here. So when you use augmentations in Open Daylight, which are very nice, right? Because when you augment a Yang model in Open Daylight, you also get all the generated code and everything. So it's really, really nice, right? But when you augment a model many times, the classes that are generated on the augmentations are generated with the names like augmentation 1, augmentation 2, augmentation 3, augmentation 4, right? So you don't really know on the code, in the code, what augmentation 1 really is, right? Because it just generates with these numbers, augmentation 1, 2, 3, and 4, right? And for the longest time, I was like, well, you know, having a piece of paper or something writing, what is augmentation 1? Okay, okay, this is open vSwitch. Oh, this is open flow. Oh, but this is open flow for this extension. So I'm writing, okay. And then I figured out that you can use this Yang statement called extension augment identifier. Then you put that string there. That string becomes the class name. So you don't have like this augmentation 1, 2, 3, 4. I mean, this stuff, I mean, is really nice. This should be like in the front page of the of the Yang tool. Like, this is how you use augmentations, right? I mean, this is like very nice. Yeah, there is a reason. It's just like me when you don't know about it, right? That's the reason. No. So this is really nice from the Yang tool's perspective, right? This extension augment identifier also has another fringe benefit. It avoids name collisions, right? When you use an IDE, and sometimes the IDE needs to pick the class name or the method name. If there are two augmentations, one, sometimes, you know when IDE like substitute things automatically for you, sometimes it picks the wrong one. So this makes it, that has this fringe benefit of the IDE picking the correct one for you. So you should know that there's no support for default statement. This is something that also tripped me. But I think these guys are working on to put that in Beryllium, because a lot of times, I mean, what I really tripped on was not that there was no default value. It's because if there is no value, the class is not even created in the data store. You have a null, right? You have to test for null, so that if the class exists, right? Because the class is not even created. It's not like the class is created and you get a value of 0 or a value of null. The class is not even created. Last but not least, this is also like probably makes the top 3. It's not totally related to Yang, but it's related to Yang and RESTconf, right? And one of the things that you see on the list over and over again is the fact that when you do a RESTconf operation in Open Daylight, if you're adding, deleting, or updating something, there's no validation on that whatsoever, right? Meaning, what do I mean by that? It means the operation goes directly to the data store and is acted upon, and then your application is notified, right? So by the time you can do something, the operation has already been done. Everything is done on the data store. I mean, what we do in the service function chaining project is to sometimes re-roll, right? We go, we say, oh, the user should not have done that, so we go and delete it, right? So one of the things that I'm big upon and ask working with some of the Yang tools guys that are on the back is to have, say, what they call a commit cohort, right? In other words, when you do a RESTconf operation, you get a notification in your application before the operation is done on the data store. This is through RESTconf, right? So you can apply business logic. This is not like, is the guy using an integer and if it's within the range? This is much more than that, right? It's applying business logic on your application, right? is the user allowed, is part of this group, has he paid his bill? All this is business logic, right? And you need to do that validation before an operation is done. There are many other caveats and recommendations, but why, right? Why, right? And you have all of these little tricks and recommendations because the crux of the problem is, or the feature, I guess, is in Yang there are many different ways to accomplish the same design. You give two people and say, represent a toaster. The toaster is like the canonical thing when you're learning Yang, right? You look at the toaster model, right? If you ask two people to represent a toaster model, they both probably represent it correctly, but they used completely different things to represent it, right? Because there are choices and groups within groups and lists and lift lists and things like that, right? So when you're designing a very rich model in the service function chain, you have this kind of very rich models, right? You might stumble upon an issue or something that needs to be fixed. But, you know, this is a self-correcting issue, right? I mean, today, in the beginning, at least, I don't know, maybe 2 years ago or so, I would stumble on many more of these caveats and little things that I will need to make a note here on the left. But today is very good, right? Today, I do all these kind of rich models, and most of them are compiled correctly. I can write, I can read them, and everything else. But I consider that a self-correcting issue, right? You create some very sophisticated Yang model, maybe you stumble on an issue, it will get fixed, right? That's the nature of it, right? Having said that, in OpenDaylight, you could probably benefit from kind of design patterns, like recommended design patterns. So, I want to create a list within a list, and I want to be able to, you know, add, remove things, and etc. So, tell me exactly if you have design pattern, a Yang design pattern for that, right? So I can just, you know, change the names or something, right? And just reuse it, right? So this is not to avoid discovering bugs. This is just so that, you know, people use the same, you know, tried and true design, right? Well, I think this is it from me. Anybody has any questions? Yeah. Mm-hmm. No. No, you can do, if you use RPCs, you know, HTTP RPCs RESTconf, it can be intercepted by your application, right? But if you're using regular RESTconf, for the lack of a better word, like HTTP put, you know, get, delete, you cannot intercept that. By the time your application get a notification, it's too late. So in SFC, we have this entire logic to prevent the user from, you know, doing bad stuff. I mean, huh?
It's only notify on change.
Yeah, exactly. After change, right? So there are a lot of, if you look at SFC projects, there are a lot of this code that says, hey, you cannot really delete a path or delete a device from a path. Hey, this device is being used. You should not do that. So we go and kind of correct all that after the fact. But what would be good is to have this kind of path integrity that I talked about. Say, if a path, if the packet is going through this path and this path has this router, you cannot remove the router from it, right? I mean, maybe the guy would like to allow that, but normally you get an error saying, no, you cannot do that, right? Go ahead.
When you generate something from the Yang model, you augment your code and regenerate the Yang model. What's the mechanism for merging those changes?
So when you change the Yang model, regenerate, everything is generated again. Everything is generated again. So the augmented code is also generated, right? If you get a Yang model and create an augmentation, right? Like you have another Yang model, and that Yang model is an augment. Okay, module A and module B is augmentation of module A. When you compile everything, module B will also be generated into code. Java code will also be generated for the augmentation. Okay, any?
Could you summarize that conversation?
So Tony was explaining that augmentations are a pattern, object extensible patterns. Is that right?
Extensible object pattern.
Yeah. So based on the question of the gentleman there, what happens if you change your augmentation, right? So the augmentations is generated again. So I hope I conveyed the goal of this presentation is to convey how Yang is powerful in general, and more specifically in Open Daylight, why you should use it, right? And if you use it with just a few things in mind, it will make your life in Open Daylight extremely easier, right? It generates Java code, not just stubs, right? Generate real Java code that you can use to integrate, to operate within the data store, get persistency and clustering. That's the goal here, the takeaway. Go ahead.
So let's say if I have my own data model. So this is the DTO, and I want to do some kind of mapping from the DTO object to my data object model. So I was thinking, could I annotate, just like in Java I can do annotation? Can I annotate things in Yang model, and then it is available in the generated code? So then I can easily map from this DTO model to my object model.
Yeah, you're not the first to ask for that, annotations in Yang, right? This is big discussion, even the ITF in Tom's working group, right? Today you cannot, there are tricks you can do, but the answer is no, you cannot annotate Yang models, right? That's in a nutshell the answer, right? There's a lot of people that would like to do that. I'm one of them, that when generating between, Yang and some other things, the annotation will create a few things for me, right? So special things depending on the language or the data structure the data representation that I'm looking at, right? So, yes.
Actually, you can do that. You need to extend the code generator. For example, this alternate identifier is an extension to the Yang language, which was introduced by us to solve that issue. So Open Daylight doesn't ID tooling for you. It's just you need to do it at a different level. So in your case, when you want to translate from the Yang model to your private model, I wouldn't go with code generation at all. I would do it using the DOM APIs, which are more powerful and are more suited to model-to-model translation and to actually driven by doing the things via Yang model. Because actually this gives you that you can load any model, annotate it to your annotations, and do the transformation based on it. That's, for example, how we implemented RESTCOM for all the Yang models and all the applications. The RESTCOM is not using the generated code at all.
Okay.
So we have a power user level APIs, really powerful, harder to use, and generated Java APIs for developers which are writing against concrete models.
Okay. So what did you call that?
There is a DOM APIs,
DOM API.
and our infrastructure allows you actually to write your own code generators, and tie it to build.
Yeah. There is a IETF draft about annotations in Yang. I don't know if it's actually expired or not, but you can take a look at that. It goes into what you can use for annotations, because certain things you might think it's safe Yang to use for annotations, it's really not, for one reason or another in terms of the grammar. So you should, I don't have the reference in my head, but there is a Yang annotations draft.
Yeah, I think that's covered in it's called recommendations for authors that are building models or something. I forget the title. I could show you where to look it up after.
Any other questions? All right.
All right, thanks. Yang models are specified in ASCII text files, so there's not a magic binary format or anything that's required, so they're easy to process. And I mean, this is maybe a matter of personal opinion, but it's fairly simple and compact and fairly straightforward to understand. Most people that I've ever talked to and shown a simple model can sort of handle that without much kind of information about what's going on. And the latest standard for Yang is defined in 6020, RFC 6020 from the IETF, which is what we use here. So what do Yang tools do? Conceptually, Yang tools in ODL generate Java code from Yang inputs, although is modeled in a config tree and an operational tree, effectively. Although there's conversations about doing other kinds of subtrees. Yang provides a couple of important other functions, RPCs, which are important for communication between the client and server. By the way, that's again originally came out of netconf itself, although it's used in other contexts. Just like with SNMP, there are notifications in Yang that can be defined, and how they're implemented is a matter of the protocol that is used. Yang tools are a set of tools that are built around processing the Yang modeling language as an input. Yang itself is a modeling language, and by the way, Yang is closely associated to netconf, but doesn't require netconf, nor does it require restconf either. It provides a modeling language that, the modeling language itself provides semantics and data, organization of data, and models can be augmented, much in the way sort of like we used to do with SNMP, where you had MIBs. So you have sort of Yang modules, which are effectively pieces of a big conceptual tree. And so Yang data, what the Yang tools are, what Yang brings to the party in ODL and in general, and talk about the Yang tools themselves a little bit. And then I'll also talk about other communities that are working on Yang models. ODL is using Yang models that are created both here and other places. So we'll talk about where those are, how you can get involved. And then Reinaldo is going to talk about best practices and recommendations and caveats for when you're actually building stuff using the models and the tools. So Yang tools is something that have been around since the beginning of the ODL project. Yang tools are fundamental to the MDSAL concept. Yang tools themselves are effectively a compiler that takes Yang as an input and generates various outputs, or can generate various outputs using what we're calling codecs. In the case of Java, generated classes are mapped to the DOM. And then again, we can output various formats that are mapped to that. And I'll show you some examples of that in a second. What's also cool about this is that the codecs are data-driven, right? So you're taking Yang, which is data, and generating various interfaces from that same input, which is really cool, because prior to this, we had to do all this stuff by hand. So I'll give you an example, like in the MDSAL,